All right, let's get right into it. Today we're going to demystify a really big topic. How do you get your code from your laptop and turn it into a live application that the whole world can see? But, and this is the important part, without all the headaches of actually managing servers. We're going to use Azure Web Apps to see just how simple this whole process can be.
Look, let's just start with a problem that I'm sure hits close to home for a lot of you. You've poured your heart into building an amazing application. But now, you're just stuck in this nightmare loop of patching servers, constantly worrying about downtime, and basically just holding your breath every time you get a big spike in traffic. You end up fighting with the infrastructure instead of focusing on what you love, which is your code.
So, how do you get out of that mess? Well, that's where this idea of a web app comes into play. You can think of it as the no-server server solution. Yeah, I know that sounds like a total contradiction, but trust me, it's the key to understanding everything we're about to cover.
So what is an Azure Web App? At its heart, it's a fully managed hosting service. This is what the industry calls Platform as a Service, or PaaS. And what that really means is you bring the code, and a provider like Azure handles, well, everything else. All the servers, all the patching, all the operating system maintenance, it's just taken care of. You get to focus on building, and Azure focuses on running it.
And one of the best parts is the flexibility. This isn't about forcing you into some brand new ecosystem you've never used. As you can see right here, it supports the languages and frameworks that developers are already using every single day, from .NET and Java all the way to Python and Node.js.
Okay, so if you're not managing the servers yourself, where does your app actually get its horsepower, right? How does it run? That brings us to our next really important concept, picking the right engine for your app.
This is a really crucial concept to grasp. Every single web app you create has to live inside something called an app service plan. Just think of this plan as the virtual plot of land for your app. It defines all the resources it gets, how much CPU power, how much memory, and how much storage. It's basically the contract you have with the cloud for its performance.
And you've got options. It's not a one-size-fits-all deal. As you can see in this table, you can start out on a free or shared tier, which is absolutely perfect when you're just developing or have a tiny personal project. But when you're ready to go live with a real application, you'll jump up to something like a standard tier to get the serious power and features like a custom domain name. Now this is where it gets really smart and honestly super cost-effective. You don't need a totally separate plan for every little app you build. This quote just nails the concept. Multiple apps can share the resources of a single plan. It is literally like having roommates to split the rent. It's incredibly efficient. Okay, so your app is live, it's running, awesome. But what happens when you need to push a new feature or fix a critical bug? How do you do that without taking your whole site down and annoying all your users? Let's talk about updating your app safely. I mean, this really is the million-dollar question for anyone running a live service, isn't it? In the old days, updates meant scheduling maintenance windows late at night and dealing with frustrated users. But with modern cloud platforms, there is a much better way.
I absolutely love this analogy because it just clicks. The solution here is something called a deployment slot, and thinking of it as a test kitchen is the perfect way to picture it. You'd never serve a brand new dish at your restaurant without trying it out first, right? Well, the exact same idea applies to your code.
And here's how that magic trick actually works. It's a simple but incredibly powerful four-step dance. First, you push your new code to a separate staging slot. This is a perfect live copy of your production site. You can test it, poke it, and make sure everything is perfect. Once you're happy, you hit a button and it instantly swaps places with the production site. And the best part, if you find a bug, you just swap right back. Absolutely zero downtime.
That safe deployment process is already a game changer. But what if we could make it even slicker? What if we could just automate the whole thing? Let's talk about getting your code from a commit in your repository to live on the website, like instantly.
This is where continuous deployment comes in. And yeah, that conveyor belt analogy, it is spot on. The goal is to set up this automated workflow so that the only thing a developer has to think about is writing and committing great code. The system just takes it from there.
So here's what that flow looks like in practice. It's beautiful in its simplicity. You, the developer, just push your code to a place like GitHub. That simple action sends an automatic signal to Azure. Azure then wakes up, pulls that new code, and deploys it for you. This completely removes the chance for human error and lets developers get back to building features. All right, so your app is live, your deployments are automated, life is good. But then, you go viral. Your app gets featured somewhere huge, and your traffic just explodes. Let's tackle that critical challenge of handling sudden, massive demand.
This chart right here, this is every developer's dream and their worst nightmare all at the same time. Yesterday, 1,000 users. Today, 100,000. In the old world of physical servers, your site would already be a smoldering crater. So the question is, how do you handle tomorrow when you have no idea what's coming?
This slide really lays it all out, doesn't it? The difference is just night and day. The old way involved a panicked phone call and someone frantically trying to add more servers by hand. The new way is autoscaling. You just create simple rules like, if the CPU load is over 70%, add another copy of my app. The system takes care of it instantly, and your users never even notice a slowdown.
And this is the real genius of autoscaling, captured perfectly in this idea. It's not just about scaling up when you're busy. It's also about scaling down automatically when the traffic dies down. This means you only ever pay for the exact amount of power you need, which is both incredibly powerful and amazingly cost-efficient.
Okay, we've covered a ton of ground: hosting, deploying, scaling, but there's one last critical piece to this puzzle. How do you actually know what's going on inside your app? We need to talk about monitoring its health.
You know, without good monitoring, you're just flying blind. You have no idea what's going on. So Azure gives you tools to track all the vital signs of your app. You can watch response times, keep an eye out for errors, and see exactly how your CPU and memory are doing. And most importantly, you can set up alerts that tell you when something's wrong, often before your users have a clue.
And for those really tough problems, Azure has this feature that's, well, it's kind of like having a built-in AI detective on your team. It can analyze your app, pinpoint potential problems, and even suggest fixes, helping you solve issues way faster than you could on your own.
So when you pull all of this together, what's the big takeaway? What's the point of all this technology? It all boils down to this one simple idea. By taking away the burden of managing servers and infrastructure, these platforms let you and your team focus all your time and energy on what actually matters, building an incredible application for your users.
And that really brings us to the most exciting question of all. When you free yourself from all that infrastructure maintenance, it just unlocks so much creative potential. So, if you didn't have to manage servers anymore, what would you build next?
In this lab, we are going to do administer pass compute options, which is implement web apps. And the task for this lab is first to create and configure Azure Web App. Second task is create and configure a deployment slot. So we are going to deploy a second slot. And task 3 is we're going to configure a web app development settings. So in this case, we will use the remote repository as a test repository to provision a new app. And then task 4 is that staging slot will make that as a production slot. And task 5 is configure and test auto scaling of the Azure Web Apps. So let's start that one. Very first thing, you have to connect to Azure portal. So here I have connected to Azure portal. Then select in search app service. Select that app service. Then click on create. You see that there are different options: web apps with database, WordPress on app service. So in this case, we are going to do with web app. And here all the options available, like different tabs. So the basic tabs, we are going to select subscription, resource group, then give a web app name. In our case, we are using not container. Option we can see that available, that you can select container, but in our case, we are using code. And the runtime stack language, programming language is PHP 8.2. And underneath operating system is Linux. So pricing plan, as per lab, we are going to select V3, P1, V3. zone redundancy, we are accepting the default. Then click on review and create. So it's validation done. Click on create. Initialization in progress. Let me come back when that is ready. It will be quick one. So click on go to resource. So task 1 is done. Now we'll create and configure a deployment slots. So deployment slot enables you to perform testing prior to making application available to the public. So and after that testing, we'll swap the slot from like this test environment that can be development or staging to production. So let's do that one. So from here, after web app provisioning, see the default domain, copy that one, open a new tab, attach that URL, and we can see that web app is running and waiting for the content. That means what the tools or application that I would like to develop. So, but web app is fine. Now go back. Now under deployment, you see that there is a deployment slots. Click the deployment slots. Now there is a add slots. You can add from here or here. So click on add and give a slot name. Here I'm going to give staging, and it's not cloning, just creating that one. So click add. So you can see now there are two slots. One is production and one is staging. So let's open the staging. So now here we are going to develop our code. Now if you see the staging slot default domain, you can see it added something staging information is there. So now what we are going to do, configure web app deployment in this slot. So for that, go to that deployments. Under deployment, go to deployment center. So here under settings is that source. So in this case, we are going to get a external git code. So git like external git and select the repository. Which is just a sample hello world code there. And branch will be master branch and click on, okay, let's say public and click on save button. So when code development is done, now go back to deployment slots. Go here, like in deployment centers. I have saved that one. Now let's go back to web app. Go to staging one. And then this is after doing my code work. So copy that default domain URL. Open the page in a separate tab. And here you see that hello world. So that is my thing, that is a code I have successfully, I'm happy with my code. Now we are going to swap that one. So for that, let's go back to deployment slots and click on swap. So it will give you that from staging to making it production. And click on start swap. So swap in progress slots. So my test is good, I'm happy, then I'm just making that as a production slot. So swapping slots successfully completed. Now, if I go back to that first one, that production one, now if I refresh this page again, so now the production page is displaying hello world. So that means that completed successfully. Now we'll configure and test auto scaling for the Azure Web App. So let's go back to this window. Here we will see that option for app service plan, and there is a option called scale out. So select that scale out. From the scaling, there are different options. So we are going to select auto scaling. In our case, we are going to put maximum burst is 2, and reinforce scale out limit 2, and then click on save. So scale out is completed. Now let's go to diagnose and solve problem section. We're going to do some kind of test here. So here you see the option for load. If you go down, load test your app. So select that one, and here is a create a load test. So you can click here or you can click here. So click create and give a test name. So load test part 03. Give kind of central. All others I'm considering taking the default one. So click on review and create. Click on create now. So as you know, load test is created now. You can select on go to resource. So from this load test scheme, now what we can do, load tested application and infrastructure. There are different options here. For our test, let's go create by adding a HTTP request. So click on create. And the test plan, here is the choose files. So here we're going to, no, we are not going for file, we are going to our app one. So click on add request. So give a request name. So I can put like prod tst request and give the URL. So this is the URL. And you see the format there. Then HTTP method is get. Click on add. So now click review and create, and then click create. So it's new like HTTP request that we are going to adding our test here. So we can see that test has been started, and a current status is its provisioning. So let it metric data come here. So you can see the live metrics value like virtual users, response time, or requests. So now you can see if you run different like times, then you can also view all test runs. There are different options you can configure. You can convert to JMX test. You can clone that one. Now we can also execute as a scheduled job. Now click on that run that we have done. So for our test purpose, we have completed our task. We do not need to continue. So what we can do, just stop this task. So select stop and click stop. So we have completed all the tasks for this lab. If you have any questions, please add into comment section. Otherwise, see you in next lab. Please subscribe to this channel.